All right, so we have the positive physics bungee jump problem. So we have a 67 kilogram student bungee jumping off a bridge as shown using an ideal bungee cord. Spring constant of 22 Newton per meter. So let's put that K equals 22 newtons per meter. And the natural length of the bungee cord is 47 meters. And neglect energy gain from the jump and neglect loss. Well, how long is the cord when she reaches maximum speed, and what's the student's maximum speed? Well, right here, this hint is given. Let me draw a straight line under here. There we go. Student stops gaining speed when the spring force is equal to her weight. So real quick, force of the spring would be equal to mg, which is equal to k x. This is the stretch. Okay, so we know m right here. We know g, that's a constant. We know k right here. So we take mg over k. Mg over k is equal to the stretch. Okay, so plug that in. We get 67 times 9.81 times, or divided by, that is, 9. What is the K? 22. So 67 times 9.81 divided by 22 is equal to 29.88. The stretch equals 29.88 meters. And how long is the cord when she reaches maximum speed? So the stretch is 29.88. And the original length is 47, so we add those together, plus 47, and we get 76.88. So we get 77 meters. Now, what is the student's maximum speed? Well, the hint for that is to say we can use the total distance, 47 plus the stretch, or 77 meters, as the height change from where they jump to where they end up right here at the point where they stop accelerating. So at this point, we can say the maximum speed can be derived from the kinetic energy at this point. So at this point, we have kinetic energy plus elastic potential energy. So this is the energy here is equal to these two. And up here, it was all gravitational potential energy. So this gravitational potential energy at the top at 77 meters, right? So at this point is 77 meters. Now we can say gravitational potential energy at the top is equal to kinetic energy and elastic potential energy, or EPE, at this point. So GPE at the top is equal to kinetic energy at that reference point plus EPE. All right, so GPE at the top is mgh. H is 77, right? And that's equal to 1/2 mv squared. This is our unknown. This is what we're trying to solve for. Plus 1/2 kx squared. Remember, x is not the total length, but the stretch, and the stretch is right here. Okay, 29.88. Make sure that that's what we put in for x. So if we multiply both sides by 2, we can get rid of the half. So 2 mgh is equal to mv squared plus kx squared. So if we're going to subtract kx squared, so 2mgh minus kx squared equals mv squared. So then we divide both sides by m. So this whole thing divided by m. And then that's going to give us v squared. So to get rid of that, we take the square root of this whole thing here. So I'm going to plug in numbers. 2 times 67 times g times 77. So times 0.81 times 67 times 2. So we get that number, 2mgh minus, and k is 22 times x squared. X is 29.88, 29.88 squared. So we take that 2mgh minus kx squared, and we get 81,414.5. And then divide that by 67, which is the mass of the jumper. We get 1215, and we take the square root of that number, and we get 34.86. So V is 34.86 meters per second. So 34, I can just put 35 meters per second here, I think. And I'm going to put 34.86. All right, so what is the length of the cord when the student reaches their lowest point? Well, this hint says set up an equation for conservation of energy in terms of stretch and givens only, then solve the quadratic. So, if you think about this, they jump out, they get to this point, stop accelerating, right? So then they start slowing down. Then they come to an absolute stop. So that means V equals 0. So which of these two energy sources goes away? This one, because kinetic depends on speed. So that means EPE here is all the energy there is. EPE. And all the energy that we started with was GPE. Well, the question is, how long is this? Well, this is equal to 47, right, the original length, plus the stretch. So we'll call this X. So this is L, the length of the bungee originally. X is the stretch, so that's the distance for H. Okay, so we're going to set this up differently. We're going to say GPE is equal to EPE at the bottom because there's no kinetic left since V is 0. So it stretches all the way and stops, and now it starts going back up. Well, we're going to snapshot that instant where it stops. Okay, so if we scroll up a little bit, we could say gravitational potential energy at the top, GPE at the top is equal to EPE at the bottom, since there's no kinetic energy left. So that means mgh, but h is the total length of the bungee plus the stretch. So we're going to put L plus x equals 1/2 k x squared. So if we put this as mgl plus mgx, oh, let me undo that. That's equal to 1/2 k x squared. So to put this in quadratic form, we need 0 on the left, so we're going to subtract both of these from the left. So we're going to say 0 is equal to 1/2 k x squared minus mgx minus mgl. So you'll look at this. Now we have the quadratic form. So this is A. A is equal to half of k, and k is 22. So A is equal to 11. B is negative mg. And C equals negative mg, and the original length of the bungee, L. We know m, g, and L. We know M and G. We know what half of K is 11. So now we just solve for the stretch. What we're solving for is the stretch, X equals. And if you have it programmed into your calculator, like we talked about, put a quadratic formula, quadratic program in, then we can put A is equal to 11, B is equal to negative 67 times 9.81, and C is equal to negative 67 times 9.81 times 47. And then you get a stretch of 90.7. So X is equal to 90.7. That's what we solve for the quadratic. And then don't forget to add the original length, because we solved this. X is just the stretch part. Then we have to add the 47 back. So the length of the chord when the student reaches their lowest point is 90.7 plus 47, so 138. 138, and that's in meters. So there you have it.